create a model for our waveguide to create a circuit based on this model. So this is our waveguide, and this is a frequency analysis. As I mentioned in our previous video. So like, for instance, you can see the effective index versus wavelengths. You can see the dispersion versus wavelengths. So now we want to export the data of Lumerical mode and import it to the other packages of Lumerical, which is Lumerical Interconnect, to do the circuit modeling and circuit calculation. So we can go to the frequency analysis and then select the data export. And in the data export, we can click the export for interconnect. So I can put the name like waveguide interconnect. So I can save it. So just we save the first mode 1, and click OK. So now we create a waveguide, a data for waveguide, and we want to export to the Lumerical. Now we export it to the Lumerical Interconnect, and now we can go to the Lumerical Interconnect. So in the solver type, so I select interconnect. So this is a GUI of interconnect, Lumerical Interconnect. This is a property window. This is a result window. We can draw our circuit here. This is the part that we can write our code. This is element library. We can type our comment here. So let's create a circuit. So for the circuit, so this is our waveguide, and this is a optical network analyzer. So we want to create this simple circuit, and we want to see the results. So let's, in the results side, so this is a dispersion versus wavelengths. So let's go to the Lumerical Interconnect. So first I select the waveguide, mode waveguide. Then I select the analyzer. In the analyzer, I select the optical, and the optical, I select optical network analyzer. So drag in and put it here. So then I connect the wiring from the input to the output. And now we want to do some setting. So I click on the waveguide. When I click on the waveguide, I see a different parameters here. Just I want to change in the length side, I want to change it to the micrometer. And like I select 1 micrometer. Then I change this length, but I want to start with 1 micrometer and 1 micrometer length. So I want to load the file. So our waveguide interconnect. Then I click on the optical network analyzer. So in the optical network analyzer, just we need to change the input parameter to start and stop. Then we need to change the unit to micrometer. Then start frequency like 1.55 to 1.6. We can increase the number of points, but we can keep this number. Now everything is good. So then we can click this button to run the simulation. The simulation is finished. So then I click to the network analyzer and see the results. So I can see, for instance, dispersion. So if you look at the dispersion, and if I plot the dispersion, I see this one. If I compare, so here there is a note that we should be take care of it. It's the unit of dispersion is sec per meter. So if I go back to the Lumerical mode and see the dispersion value, plot in a new window, and if I want to compare this, this is a Lumerical mode, and this is interconnect. So in the Lumerical mode, we can see here, like in this point, so the dispersion is 395, but here is 3.95 e minus 10. So the unit of dispersion here is picosecond nanometer kilometer, but here is second per meter. So to convert unit from the Lumerical mode to the interconnect, so dispersion unit in Lumerical mode is picosecond nanometer kilometer. So, and the Lumerical interconnect is second per meter. So if we want to convert this unit to this unit, so like we can start with, for picosecond, we can put 10 minus 12, nanometer 10 minus 9, and kilometer 10 to 3. So then if we multiply this value to the wavelength length, so we can see that we have 10 minus 6 waveguide lengths. Then so the waveguide length is meter. So our waveguide length is 1 micrometer. So 1 micrometer is 1 minus 6. So 10 minus 6 and 10 minus 6 is 10 minus 12. So we need to actually multiply this value 395 to 10 minus 12. So after multiplying, so we can get this number, 3.95 e minus 10. So this is a little description about the unit conversion from the Lumerical mode to the Lumerical interconnect. It's the same, it's the same plot. So we can plot the group velocity. This is the group velocity and group delay. So this is a group delay. Now let's increase let's increase the length of waveguide to like 50 micrometer. So if I increase the 50 micrometer and redo the simulation and check the results and plot the dispersion again. So this is the dispersion of 50 micrometer. And if I change to the length to 100 micrometer and run the simulation and see the results of dispersion, so we can see that the the value of dispersion is increased around 2 times. Like, it means that higher waveguide lengths, so if we increase the length of waveguide, so the value of dispersion also is increased, because in this case, we include the waveguide length in the dispersion value, like as you see in this equation, in this relation. Okay, so now next, so let's close this window. If I plot the transmission, so this is a transmission of the waveguide. So as you see here, we have a standing wave. So why we see this sinusoidal shape? So if you look at the analytical method that I described before, here, you see that in the region of the core, in the core region, we have a standing wave solution in the core, which is sinusoidal behavior. Now, for this reason, we have this sinusoidal behavior. So if we decrease the length, of the waveguide, like to 50 micrometer, and rerun the simulation and see the transmission on the same plot, the blue is belong to 100 micrometer length, and the green is belong to 50 micrometer. As you see, the wavelength, the periodicity of the sinusoidal shape it changes based on the waveguide length. So in the next, I can show you how you can create a compact model library for the Lumerical Interconnect. What does it mean? It means that, so as you see here in this picture, we used a waveguide model that exists in the Lumerical Interconnect. So I use the mode waveguide, but sometimes we need to have our waveguide. We need to create a simple, separate folder. We don't want to use a Lumerical Interconnect built-in library. We want to use our waveguide model that we created before from the foundry or from the other softwares, and we want to use that waveguide in the Lumerical Interconnect. So I will show you in the next video how we can do it, how we can use a compact model library, and how we can generate our waveguide model in the Lumerical Interconnect.